Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Subject is matrices and calculus. The topic we are going to discuss on the find the rank of a matrix by using Echelon form and normal form. That means rank of a matrix by Echelon form and normal. Here we know that many different methods are there to find the rank of a matrix, generally by using the determinant process and again the Echelon form and the normal form. And Gauss-Jordan method also, we need to find the rank, find the inverse of a matrix by using the inverse of a matrix, that also we obtain the rank of a matrix. But today we are going to discuss only the two methods, one is the Echelon form and normal form. Before going to discuss the Echelon form, here, what is the meaning of the Echelon form? Sometimes the Echelon form is also known as a row Echelon form. And what is the meaning of actually the Echelon? That means first we need to understand. And based upon the meaning of the Echelon form, then how to identify the Echelon form, and based upon the Echelon form, how to find the rank of a matrix. That means what is the concept of the rank of a matrix by using the Echelon form. And similarly, we need to find the rank of a matrix by using the normal form. And what are the standard conditions, and again how to reduce it to like normal form and Echelon form. Here, the meaning of Echelon form. The meaning of Echelon is nothing but the Echelon is a military term that refers to a specific type of formation of troops, ships, and airplanes, like etc. Here, generally, here these are the observation while the defense, like according to the troops and ships and air force, like based upon these are the some structures. Here, while we are going to observing here some of the Echelon, the formation. Here one is under these are the like four formations, like five formations. Out of these five formation, we need to assume, we consider this is the Echelon form. And how to identify? That means how to define this is the Echelon form. When we are going to observing something certain, these are the formations. For example, Echelon form. What are the conditions to require to Echelon form? That we need to understand properly. Here, a matrix is like according to this is the matrix. This matrix is indirectly it is a Echelon form. And based upon this is the standard form, how to define that Echelon form? That means a matrix is said to be in Echelon form if satisfy some of the conditions. Based upon this is the right side, the matrix. And what are the conditions like? Zero rows. That means whenever the matrix is said to be like if all the rows are zeros, that is called as a zero rows. That means in that given matrix, like formation of matrix, if the zero rows are occur, that means if zero rows, if any exist, that should be considered in the last row. That means the zero rows, if any exist, they should be below the non-zero row. That is the meaning of whenever the matrix is said to be Echelon form, if the rows are existed, you put in the bottom. That is the meaning of the first statement. And second one, here the first non-zero entry in each non-zero row is equal to 1 or unity. That is the meaning of here, whenever the rows is a non-zero row, in that particularly the first row should be either it may be 1 or any non-zero number. The non-zero number, it is here we call as a unity. That unity is nothing but any non-zero number. Sometimes it is 1 or sometimes it is -1, sometimes it is 2 or -2 or something 5, 1/2, whatever it may be. That is the meaning of non-zero number. First non-zero element should be, it is a 1 or unity. That is any number. And here we need to remember the main important is, that is the third condition. the number of zeros before the non-zero number, it is less than the number of such rows in the next row. The meaning of here, while we are going to observing in this right side matrix, for example, here in this matrix, here one of the zero row is existed that I kept in the bottom. That means here first row, first condition it is satisfied. That is the meaning of if any zero rows are available, you put in the bottom. That is the last row. And second one, in the non-zero row, that means the first row and second row, third row is a non-zero number. Because of one is a non-zero number, it is existed. Due to that reason, the three rows are called as a non-zero number. The first non-zero number, it should be any one, like 1 or unity. That means either it may be 1 or it may be -1 or it may be 2, whatever it may be. That is the meaning of it is a non-zero number, it should be satisfied. But here I treat it as 1 is our understanding purpose. That is the meaning of the non-zero number, the first non-zero element should be either 1 or any non-zero number, that is a unity. And here the third condition is, while we are going to observing these are the three non-zero rows, the first one, second one and third one, while we are observing properly, that before that, for example, in that before the one element or two element, the number of zeros are, here it is a two number of zeros, and before the non-zero number, here the zeros are, it is a 1, and before the non-zero number, it is a zeros are no zeros. That means comparison between the 1 by 1 row, it is a before the non-zero number, it should be the zeros are increasing, like according to the top to bottom, if it is observing, it is increasing, the bottom to top, it is a decreasing order. Therefore, these are the three conditions are required to satisfied, then the matrix is said to be echelon form of a matrix. That means we need to remember here first is the zero rows are occur, we put in the last row, and second one, the first non-zero number, it should be 1 or it is a non-unity, and the third one, before the non-zero number, 1 to other row, it is a increasing order, or top to bottom it is a increasing order, or bottom to top is a, that is a decreasing order, that is a before the non-zero number, the zero numbers are, it is a decreasing order. And based upon these are the three conditions are satisfied, then the matrix is said to be echelon form of a matrix. And based upon this confirmation echelon form, we need to identify what is the rank of a matrix. That means if the three conditions are satisfied, then the matrix is said to be echelon form of a matrix. And based upon this echelon form, the rank of a matrix is nothing but the number of non-zero rows in the echelon form of a matrix is said to be the rank of a matrix. Here, whatever we consider this is the given matrix, here right side is a matrix. In this matrix, here the number of non-zero rows are, that is a 3. Therefore, that particular matrix rank is a 3 is the rank of a matrix. Therefore, we need to remember like this, it is the number of non-zero rows in the echelon form of a matrix is equal to the rank of a matrix. And based upon this one, we need to identify like some of the example here. We assume that these are the sum of the examples, the echelon form of a matrix. For example, first matrix, that is a 4 by 4, and the second matrix, it is also 4 by 4. The third one, it is a 3 by 4, and again the other one, it is a 3 by 4, and again these are the sum of the example for the echelon form of a matrix. See, for example, if we need to observe that first one, in this first example, here there is no zero rows. That means here first condition it is not required to here satisfied. And if it is if it is available, the zero rows we put in the bottom. And again the first matrix, it is clearly the first non-zero element should be 1 or any unity. That is automatically any matrix is satisfied. The third condition, it is very important to understand. It is for example, the last row, the first non-zero element, it should be 1. Before the 1 value, here the number of zeros are 3. And second one, first non-zero element should be 1. before the number of zeros are 2. And here the second row, the first non-zero element should be minus 2. Before the 0 is a 1. And here first non-zero element should be 1. Before that there is no zeros. While we are observing here, clearly it is a the number of non-zero row, number of non-zero elements. Before that the zeros are like bottom to top, it is a decreasing order. That means it is number of 3 zeros and number of 2 zeros and number of 1 zero, that is no zero row. That means it is a top to bottom, it is a decreasing order. Therefore it is clearly the Echelon form. If we need to identify, like if it is a Echelon form, based upon this Echelon form, the rank of a matrix is 4 only. And similarly, for example, the second example. And under the second example, here, while we are observing here, the 0 rows is available, I kept in the bottom. Therefore, in this matrix, the first condition it is existed. But whereas in the first example, the 0 rows is not available, therefore, we are not concentrating on the 0 row. But whereas in the second example, the 0 rows is available, I kept in the bottom. And here, the first non-zero element should be, it is a 2, and first non-zero element should be 5. The first non-zero element should be 1. Before this third row, the first non-zero elements are, the numbers are 2. And again, the second row, before the first non-zero element is a 1. And again, before that, there is no zeros. Therefore, the bottom to top, it is an increasing, decreasing order. Therefore, in the second example is also the Echelon form of a matrix. Therefore, the rank of a matrix is the number of non-zero rows. The number of non-zero rows in this Echelon form, the rank is 3 is a matrix. And coming to point, that is the third example. The third example, in here also, it is not involving any 0 rows. Therefore, the first condition, it is not required here. The second condition, the first non-zero element should be either 1 or any unique number. And first non-zero element, it is 1 or unique number. And first non-zero element, it is a unique or 1 number. That second condition is also clearly satisfied. The third condition, before the non-zero number, the zeros are, it is satisfied, decrease. Therefore, it is the number of zeros are 3, the number of zeros are 2, the number of zeros are 1. That means it is a bottom to top, it is a increasing, decreasing order. Therefore, it is also the Echelon form of a matrix. Therefore, the rank of a matrix is equal to the number of non-zero rows in the Echelon form. Here, it is Echelon form is the number of non-zeros are 3. Therefore, rank is 3. And similarly, here 0 rows, it is not required, not available. The first non-zero element should be 4. The first non-zero element should be minus 2. The first non-zero element should be 1. That means first and second, it is clearly satisfied. The third condition, before the number of non-zeros, here it is a 3. And it is before the non-zero number, it is 1. And before the number, it is there is no zeros. In this matrix, it is clearly also, it is also decreasing order. And here we need to remember, it is a decreasing is nothing but it is not compulsory 3, 2, 1 like that. It is a 3 and after that 1 is also directly, it is a decreasing. Therefore, it is also a Echelon form of a matrix. And based upon this one, here also it is a number of non-zero rows in this particular matrix is equal to the rank is a 3 is a matrix. And further, here 0 rows are not available in this matrix. And again here also, the first non-zero element should be 4. The first non-zero element should be minus 2. The first non-zero element is 1. And second condition is also either 1 or any unique number, that is the meaning of non-zero number. Therefore, before the number of non-zero number, the zeros are, the bottom is 2 zeros and 1 zero and there is no zeros. That means the bottom to top, it is like decreasing order. Therefore, here also that it is satisfied the Echelon form. The rank of a matrix is the number of non-zero rows is equal to, that is a 3. Therefore, rank of a matrix is the 3 is the condition. And similarly, coming to point that one more example, it is also that 4 by 5 matrix. And here also there is no zero rows. Therefore, first condition itself it is not required. The second condition, the first non-zero element should be it is a minus 3. The first non-zero element should be 1 by 2. The first non-zero element should be 7. The first non-zero element should be 1. Therefore, 1 or unity it is also existed. And the third condition, comparison between that bottom to top, that is a before the non-zero number, it is a first 4 number of non-zero rows, and here 3 number of, that is a zeros, and here the 0 rows are 2, and here also zeros are 1 only. The top to bottom to top, it is also clearly it is a decreasing before the number of non-zero row, number of non-zero element, the zeros are it is a bottom to top is a in decreasing order. Therefore, this matrix is also clearly the Echelon form of a matrix. And based upon this one, the number of non-zero rows in this matrix, the rank is 4 is the rank. Because of the number of non-zero rows are 4, therefore rank of a matrix is the 4 is a matrix. Therefore, based upon these are the some example we identify here. These are the such type of identification for the Echelon form of a matrix, and based upon the Echelon form, we clearly understood how to identify the rank of a matrix. For example, we need to identify which of the following matrices are in Echelon form. That means, based upon these are the some examples, we need to identify which one is the Echelon form of a matrix and which one is not Echelon form of a matrix, and based upon that, what is the rank of this matrix. That is based upon the understanding level of the Echelon form, we should identify. And first one, it is a Echelon form because of that 1 0 row is available, we kept in the bottom. And again, second condition, non-zero row is non-zero element is satisfied. And third condition, before the non-zero number, it is a first one, it is a 1 0, and there is no zeros. Therefore, it is clearly bottom to top is decreasing. Therefore, it is also Echelon form. And here it is Echelon form. Therefore, rank is nothing but number of non-zeros in this matrix is equal to that is 2. Therefore, the rank is also 2 is a matrix. And similarly, the second one, first condition existed, second condition existed, and the third condition is also existed. And here also the rank of a matrix is the number of non-zero rows is equal to the rank is 3 is the rank. Therefore, it is a Echelon form, it is the rank is 3. And now further it is a C is a matrix. Here the 3 rows that 0 0 2, 0 1 4, 0 0 3. While we are going to observing in this problem, it is a not Echelon form because of here the 0 rows we forgot about that. The second condition that also forgot about, it is not required that much, and here the third condition is not satisfied because of the before the non-zero number it is a 2, and before the non-zero number 1, before the non-zero number it is a 2. While we are going to observing in this matrix, it is not Echelon form because of it bottom to top, it is not at all satisfied the decreasing. Therefore, it is up to here, it is a decreasing, but in this case, it is not a satisfied. Therefore, it is not Echelon form of matrix. Therefore, rank is we are not identified. Therefore, and next one, fourth one, it is a matrix is a 0 rows available. I kept in the bottom, and non-zero number, it is also no problem. The third condition before the non-zero number in the second one is also satisfied comparison to first one. Therefore, it is the Echelon form. But in this case, the rank of a matrix is the number of non-zero rows is equal to 2. Therefore, rank is equal to 2 is a condition. And similarly, here fifth one, here the first condition it is not required. The second condition it is not required because of it is automatically by default it is satisfied. And the third condition before the number non-zero it is first element is 1, the second element is zeros are 3, 2, and zeros are it is 3. That means it is not at all bottom to top, it is not a decreasing order. Therefore, it is not Echelon form. As per we Echelon form, we need to satisfy bottom to top, it is a decreasing order. And here sixth one, here it is a first condition is okay, second condition is also okay. The third condition before the non-zero number In this case, it is a two zeros and it is a one zero and there is no zeros. That means it is clearly satisfied the echelon form. Therefore, based upon this, the rank is nothing but the number of non-zero rows in this echelon form. It is equal to 3. Therefore, it is a rank is a 3 is a condition. And further, the seventh one here 4 by 4 matrix. The matrix is a 0 rows available. I kept in the bottom. And again, the second one, the non-zero number, it is satisfied. The third condition, before the non-zero number, it is 1. Before the non-zero number, it is 2. Before the non-zero number, there is no condition. But here, the condition is not satisfied because of the bottom to top, it is increasing satisfied, but we require the decreasing. Therefore, the matrix is a not echelon form. Therefore, we are not identify the rank of a matrix. And further, here also, first one itself, it is not satisfied because of 0 rows as per the conditions echelon form. We need to keep in the put in the bottom. Therefore, first condition itself it is does not exist. Therefore, it is a not at all echelon form of a matrix. And these are the sum of the example for the echelon form of a matrix. And based upon this echelon form, we identify clearly what is the rank of the matrix. And further, for example, rank of a matrix by reducing it to echelon form. That means after understanding level of the echelon form, if the matrix is given how to reduce it to echelon form, then how to find that echelon form rank of a matrix. That means the number of non-zero rows in the echelon form is equal to the rank of a matrix. That is the main concept which is involving. And again, here we are going to discuss find the rank of the following matrix by reducing it to that is echelon form. Here, we need to remember under the echelon form, we should apply only that row operations, should not apply any column operations. Here, for example, the problem 5, 3, 14, 4 and 0, 1, 2, 1 and 1 minus 1, 2, 0. While we are going to observing, here we need to remember, here find the rank by using the echelon form. Under the echelon form, we need to apply only row operations based upon the conditions. We need to keep in our mind that is a 0 rows and again the non-zero number and again the before the non-zero number it will be increased order. And based upon this one, first we need to try as well as level as based. It is a interchange R1 and R2. And based upon this interchange that R1 and R2 here, because of if it is possible to change that 5 in presence of 1, here it is existed, it is a 1 value. Therefore, first immediately we need to interchange that is R1 and R2, R1 and R3. By applying that R1 and R3, here we R2 we are not worried about. Therefore, interchange that R1 and R3. It is the values are changed to 1 minus 1 to 0. That means interchange that 1 R1 and also R3, and rest of the row is as is. Now further, we need to remember according to that before the non-zero number it is a decreasing order. Based upon that, here below the 1 value it should be 0 already existed. Now we make it that is a 5 is equal to 0. That with the help of that is a 1 value. Therefore R3 by applying according to R3 minus that is a R1, we obtain that clearly. We reduce it to first row is no change and second row is also no change. The third row it will be 0, 8, 4, comma and also 4. And one more, it is also not echelon form while we are going to remembering according to the upper triangular matrix whatever it may be in our mind. Here below the values are it is satisfied, but it is required to satisfied. Based upon that, yet we need to change that 0 by using that R2 is a value. For the purpose of this one, we need to apply that R2 minus that is 8 into R1. Therefore, by applying according to this operation, the first row and second row there is no changes. The third row it will be that is 0, 0, minus 12 and minus 1. And here it is clearly satisfied as per according to the conditions of the echelon form. It is a 0 row, it is not possible. And again the first non-zero number it is clearly, and again the before the non-zero number it is clearly that bottom to top it is satisfied. That is a decreasing order. Because of it is before that non-zero number the zeros are 2 and zeros are it is 1 and zeros are it is a no number. That means it is clearly satisfied the decreasing order from bottom to top. Therefore, it is clearly it is called as a echelon form. And based upon this echelon form, As per condition, the number of non-zero rows in the echelon form. Here, the number of non-zero rows is equal to, that is a 3. Therefore, the rank of a matrix is equal to, clearly it is a 3 is the rank. And second example, for example, similarly, find the rank of the following matrix by reducing it to echelon form, and based upon here also, for example, the matrix is 1 2 3 0 and 2 4 3 2 and 3 2 1 3 and 6 8 7 5. First of all, let us assume that a given matrix is A, and based upon that, we need to keep in our mind here, one by one, the first term element below the values are, we need to reduce it to 0 based upon applying here R2 minus 2R1 and R3 minus 3R1 and R4 minus 6R1. By using these operations with the help of the element, key element is the 1, the matrix it will be, it is the first row is there is no changes, therefore 1 2 3 0, and again the second row it will be clearly there is a 0 0 minus 3 2 and 0 minus 4 minus 8 3 and 0 minus 4 minus 11 5. And now again further we need to modify it. Here already it is existed, it is 0. Now we need to reduce it to 0. That means it is also based upon either any possibilities. Here R3 minus R2, whatever maybe R2 divided by interchange R3, that is interchange, like R2 interchange R3, we need to change it. By applying R2 and R3, the matrix is reduced to like this. Now further we need to reduce it to 0, that with the help of that R4 play and also R2. Here while we are going to apply, that is R4, that is a minus R2, the matrix is reduced to here R1 and R2, there is no changes, and moreover R3 is also no changes, that R4 only we are going to change. And here clearly that below the terms are which is 0 and before the minus 4 is 0. Now our target is we need to reduce it to minus 3 is equal to also 0, and based upon here it is R4 minus R3, the matrix it will be reduced to that last row is the minus 3 is equal to change it to 0, and again the 2 is also change it to 0. By applying this, the matrix is reduced to like this. And while we are going to observing here, it is clearly we obtain the 0 matrix, first condition existed, and further it is not possible because of it is the second condition is existed, but the third condition is also clearly existed because of before the non-zero number, it is a first element, it is a zeros, two zeros and one zero, and there is a no zeros. That means the bottom to top it is also clearly satisfied. Then based upon this one, it is a clearly echelon form of a matrix. And conclusion of this based upon the echelon form, the rank is nothing but the number of non-zero rows in the echelon form. Here, the echelon form, the number of non-zero rows is equal to clearly it is a 3. Therefore, the rank of a matrix is equal to here also the 3 matrix. And further, any matrix is given based upon the echelon form by using the row and column operations. We need to reduce it to a standard form. The following conditions according to the 0 rows if it is possible, and again the first non-zero number that is automatically by default. Again before that non-zero number, it will be reduced to 0. The bottom to top is increasing order, that is a decreasing order, and based upon that, whatever it is a possible days, we need to change it. For example, here also we need to observe R2 and R4, and again here also we need to further 0, and it is also 0 by the key element of one value. Then the matrix is R3 plus 2R2, R4 minus 3R2. Then the matrix is reduced to clearly this matrix. And here further it is not possible to move in the next step because of it is not required. Here the 0 rows are got it, and therefore the second condition is also satisfied. The third condition is also clearly satisfied because of the first non-zero. It is clearly it is a 2 0 rows, and before the non-zero number the zeros are 1. It is there is no zeros. Therefore, based upon this concept, the number it is also clearly satisfied the echelon form of a matrix. And here the rank of a matrix is equal to the number of non-zero rows in this echelon form. But in this echelon form, the matrix and number of non-zeros are it is a 2. Therefore, rank of a matrix is equal to 2 is a rank matrix. And further, like any matrix are given, we need to find the solutions. For example, it is also by interchanging any other method any operations, we need to reduce it to values. For example, like this. And here for one more step is also required because of it is repeated. We need to either interchange that R3 and R4. Otherwise, directly we can apply the 6 R4 plus R3 is also it is required. No problem. The two operations it is possible, 6 R4 plus R3. Otherwise, after interchanging R3 and R4, we can apply the row operations. And here it is also clearly matrix. The before the non-zero number it is a 3, and before the non-zero number 2, and before the non-zero number 1, and before the non-zero number there is no zeros. That means it is clearly the bottom top it is also the decreasing order. Therefore, the rank it is also echelon form. Therefore, the rank is equal to the number of non-zero rows. Therefore, here the number of non-zero rows is equal to it is a clearly what is a rank matrix. Like any matrix are given, we need to find out. For example, these are the practice problems. Based upon these are the some example, we need to reduce it to echelon form. And after confirmation that echelon form, then only we need to find the rank of a matrix. What is the rank of a matrix? And here clearly some more exercise problems. These are the consider. We can practice, and again here first one, the solution itself, it is a rank is a 2. That means number of non-zeros are 2 is required only, and further we need to modify it. And second one rank is 3. That means number of non-zeros are 3. And again the rank is also here, it is a 2. That means the last 2 rows are it is reduced to 0. And here rank is 2. That means the last 2 rows it is also reduced to 0. And here rank is 2 means 1 0 rows is available last row. And similarly, all these problems are also we need to find out with the help of the corresponding rank of a matrix. Given the solutions, you need to practice the problems. And further, this is the method, particularly the rank of a matrix by using the echelon form of a matrix. And similarly, today we are going to discuss about the and some more problems. Like for example, these are also some more problems. We need to do that. Like these are the some more example to practice the problems based upon under the echelon form of a matrix and with the help of the echelon, that is rank also matrix. And today we are going to discuss that additionally the find the rank of a matrix, but whenever the matrix is the normal form. That means by using the what are the conditions reduced to normal form, and what it is called as a normal form also like a canonical form, and what is the general structure of the canonical form or normal form, and based upon that confirmation that canonical and normal form, how to identify the rank of a matrix. Now we need to discuss what are the conditions to require to satisfy the normal form or canonical form. Based upon that, what are the operations? And for example, every non-zero matrix, that means any matrix is given either the rectangular matrix or square matrix. That is the meaning of order is doesn't matter, it is not a square matrix or any rectangular matrix. That is the meaning of every m cross n matrix, every non-zero m cross n matrix can be reduced to the form in the form of IARE00 is called the normal form, and sometimes it is called as a canonical form with the help of that is elementary transformations under here rows and column. Where we discussed in the previous method, that is echelon form by using the row operations, but here that normal form or canonical form, not only row, it should be applying including the column operations. And based upon such type of the row and column operations, we need to reduce it to the standard form. And this is the not only standard form of that IR00, and other methods are also other standard forms are there, that is alternate, where here IR is a unit matrix of order R. That means, for example, R here, IR is a unit matrix of order R, and R is the rank of the matrix. And also with the help of that element row and column operations, again we need to reduce it to here some other like standard types are there, that they are the following matrices are also known as a normal form of canonical form of a matrix, and these are the like one by one matrices IR, IR0 and IR00, IR00. Sometimes depend upon the matrix. While we are going to apply the row and column operations, the matrices are reduced to such type of these are the matrices. Like these are also matrices are known as like normal form or canonical form. That means the conclusion of under this is the normal form. Here, when the matrix is said to be normal or canonical form, the matrix element should be only zeros and ones. That zeros and ones should be satisfied the unit type of the matrix. Either it may be I2 or I3 or I4 or something like that. That is the meaning of unit matrix. It is satisfied indirectly zeros and ones only that. And corresponding examples are given. First example I3 and again I30. That means here it is a I3 and again here it is I3 and again after that it is a I3 is a matrix. These are the like four different types examples, suitable example for that normal form or canonical form. Any matrix can be reduced to with the help of like following any one of the forms which is compulsory available. And again here, for example, we need to understand some example. What are the example for like a previous example like Echelon form? Now also some example for the normal form or canonical form. Based upon that, we need to identify like further example. For example, first one and second one and third one and fourth one. And similarly, like these are the some of the example. And while we are going to observe here, we need to observe one by one. The first one, it is a not a canonical form because of it should be required like any zeros ones. It is satisfied, but it is a not a identity matrix. It is a not in the form of I2. And why? Because it is the middle of the term. It is a zero is available. Therefore, it is a not a normal form. Here, if it is required, the normal form, we need to interchange by rows and columns. Then only it is a normal form. But directly, this matrix is a not a canonical form. Therefore, it is not a canonical form. No conditions. And similarly, for example, the second one, if you are considered, it is clearly the matrix is I2. That is unit matrix order I2. None other values are totally 0. Therefore, the rank is equal to that is a 2. And here also the matrix is a I2 because of the unit matrix, and it is a not a can normal form. And second one it is existed, and it is also not existed. Therefore, and further, and again the this one coming to it is also not a normal form. And again next one it is also not a normal form, not a unit matrix. And again the next one it is a S, that is a unit matrix with the help of the I3. And again here also not a normal form. And again further it is also like treated as a normal form, like no, it is not a normal form. And it is also not a normal form. We need to satisfy the standard form. We need to repair with the help of this matrix, but it is not clearly satisfied in the form of like this. After modified that interchange rows and column, the matrix is reduced to normal form. And similarly, this matrix is also not here after changing interchange that R3 like R4 and also R1, then only the matrix is reduced to that normal form. And based upon some example to identify, then we need to discuss the problem based upon the normal form or canonical form of a matrix. For example, here ways to find the rank of a matrix, the echelon form. Under the echelon form, only it should be applied the row operations, and under the normal form, remember that using the rows and columns map operations. For example, find the rank of a matrix by reducing to the canonical form or normal form. Here this is the matrix. While we are going to observe so many operations, so many different type of the operations, it is possibilities. Here not only one type of the operations. While we are going to apply any number of different operations, we get the rank of a matrix. But if by applying any different type of the row and column operations, finally we get that only one type of the rank of a matrix. That means, for example, by applying one different operations and again operation one other different operations, we are not getting any different type of the rank of a matrix because of the property of the rank of a matrix. Every matrix will have a rank. The matrix is a rank of a matrix is always it is a unique matrix, unique rank of a matrix. matrix. That means we are not getting by applying the different operations. That is not getting any different type of the rank of a matrix. For example, here in front of us, this problem is a one is a see here we need to require that zeros and ones only element. The final matrix should be the unit matrix only. But here that particularly the first row 2 like that. Here one option is in front of C1 by 2, one option, and again other option it is a C1 interchange C2. This is also other option, and again other option is a C1 minus C2 is also one more option. That means our choice depend upon that. If we need to reduce it to first element should be it is a one, we need to use according to these are the different operations in our mind. That is for here I'm going to apply according to it is a by applying the let us assume the matrix. I need to apply it is a C1 by 2. That means from that according to these are the three conditions I selected that is a C1 by 2, and based upon the C1 by 2 then further it is a matrix is reduced to like this is the matrix, and rest of the C2 C3 C4 is no changes. And now further we need to reduce it to 1 with the help of this one we need to reduce it to 0. That means here also two options are there. That is like R3 minus R2, we need to get the 0, and again R4 minus R1, sorry, R3 minus R1, we get the 0, and R4 minus R1 is also we get the 0. And other options here, if you want to follow this side, that is a C2 minus C1, this is also 0. That is depend upon our choice. Here I choose that here according to based upon that R3 minus R1 and again R4 minus like R4. Therefore, the matrices are nothing but here first row, second row there is no changes. The third row and fourth row it will be changes. And based upon this one, here we obtain the matrix. And further, here it is already reduced to 0, while here we call according to the standard form of the rank of a matrix, that is a normal form. And again further we need to reduce it to 0, that with the help of the first row it is a C2 minus that is a C1, and C3 that is a minus 3C1, and again C4 minus that is a C1. That is a key element is it is a 1. Therefore, by applying according to that C2 minus C1 and again C3 minus 3C1 and C4 minus 4C1, the matrix is reduced to clearly this is the matrix. That means here below the first element is 0, and again the other side is also 0. Next, our target, the diagonal element should be 1s, and based upon that, here we need to reduce it to 1. And here also in front of us, that many options are there. That is one is like R2 minus that is R3. You get that one value, and again interchange other option that is C2 interchange that is also C4. These are the some two options are there. That based upon this one, I'm going to apply here that is a C2 interchange C4. While we are going to applying this one, we obtain this the matrix. Now again, this is also we obtain the 0. This term is also we obtain the 0. And further, with the help of this the one value, we need to reduce it to 0 and 0. Based upon with the help of the key element that is R3 minus R2 and again R4 minus that is a 2R1. Then we get the values are zeros. Therefore, here R3 minus R2 and R4 minus 2R2, then the values will be 0. And further, again we need to here it is completed and it is also completed and it is also completed. Now our target is reduce it to 0 and reduce it to 0. With the help of again it is a C3 minus 4C1 C2 and again C4 minus that is a 3C2, then the values it will be 0. Therefore, based upon this one, you obtain the matrices like this. And further, again, it is a required 1 is over. We need to reduce it to it is also 1. Then here options are either interchange that is a C3 interchange C4, and otherwise after dividing like the C4 divided by minus 1, the matrix is reduced to like values. Therefore, based upon this one, it is I am going to change that is R3 divided by minus 1. This is also another in front of us, and again R4 divided by minus 2 minus 1 also. Therefore, by using this one, we obtain this the matrix, and it is also not echelon, not a normal form. Here we obtain the 0, and we obtain the 0, and we obtain the 0, and again we obtain the 0. But here it is required one value. Therefore, by interchange that is the C3 and C4, then only it is a clearly satisfied the normal form. Therefore, we applied that C3 interchange that C4, the matrix is reduced to this matrix, and it is clearly from here to here it is a 3 by 3, that is a unit type of the matrix. Therefore, conclusion, it is clearly satisfied the normal form of a matrix. Therefore, rank of a matrix, it is a unit matrix of order is a 3. Therefore, rank is a 3 is a matrix, because of which is a normal form. Therefore, the rank of a matrix is equal to 3 is a condition. And similarly, any matrix are given, then we need to reduce by using the normal and canonical form. We reduce the problem. After confirmation, like not only one type of the row and one type of the column operation, but keep in our mind, by applying any different type of the row and column operation, the matrix is reduced to like that is unique element, that is 0, 1 only. And again, finally, it is required to satisfy any one of the form, that is IR, like IR0 and IR00, whatever, depend upon the matrices, we reduce it to like normal matrix. After that confirmation of the normal form only, we can say what is the rank of the matrix. For example, these are the operations, and again further we need to reduce it to 0 and 0 and 0. Based upon that, we get, and further again it is a 0 and it is also 0. The matrix should be, and again now we need to reduce it. It is also one value, that either the with the help of the C3 divided by 3 or C3 minus C4, by any operations we can apply, then we get the value is 1. And again similarly, last C4 by 2 also we get the value. For easy convenient purpose, we can do that. And C4, it is reduced to 0, that C4 minus C3, then the matrix is reduced to like this. Therefore, it is clearly from here to here, it is a clearly, that is I3 0 0. Therefore, the rank of a matrix, it is a unit matrix of order where I3, that where R is the rank of a matrix, here R is equal to 3 is the matrix. Therefore, the rank of a matrix is equal to 3 is the matrix. And similarly, any matrices are given, we need to do that. Like it is not any different type of the problem. Like again the column operations, and further it is also the column operations, and again further also you need to apply in the column operations C3 minus C2 and C4 minus C2. The matrix is reduced like that I2 0 0, therefore which is a normal form. Therefore, the rank of a matrix is equal to 2 is the matrix. Like any matrices are given, we need to reduce. These are the some example for this to find the rank of a matrix by using the normal form. Like these are the some examples for to finding that particularly like a normal form. Like first one is rank 1, means that only one element, other values are zeros. And the second one, rank is 2, means that is the other values are like I2 0 0. And again the rank is, we need to get that I4, that means it is a 1 0 0 0 0, and it is a I2 0 0 0, and it is a I4, and again here also I3 0 0, and you get here the rank is 1, means 1 0 0 0, and the sixth one, the rank is 3, means that is I3 0 0, and next one I4, that means that is also rank is a I4, in last one that I2, that I2 0 0 0, and last one which is the least one, it is a I4, where based upon this type of the matrix we obtain that. By conclusion of this one, it is a IR is a nothing but a unit matrix of order R, where R is the rank of a matrix. And these are the such type of them, like based upon the echelon form and normal form, we need to find the rank of a matrix. Under the echelon form, we need to apply only the row operations. That canonical form, under that by using the row and column operations. Based upon these two methods are also, we need to find the rank of a matrix. And further any clarification, please give me the reply, or please just share the link. Thank you. Any more questions, please give the reply. Thank you.
Like, share and subscribe. hit the bell icon for more updates.